We're starting chapter 7. Let's get into the weeds here. Chapter 7 is on the normal probability distribution. This is the one that gives us the bell curve. The normal probability distribution has a nice little bell curve. Straight up gate, stack crunch stats, calculators. Normal. So it's symmetrical. It's a symmetrical distribution. Bell shaped as well, not just symmetrical, but bell shaped. If anyone in here is ever going to pursue higher mathematics, like calculus, fun fact, but not necessary for most students in here, the inflection points are at plus or minus 1 deviation. That just means where it starts going from a curving looking up to a curve looking down. Inflection points is where the curve looks like a pull upside down. That's where inflection points means. It's a very much a calculus thing. That's just a fun fact. Facts you should know. The area under the curve, under the entire curve, all the way to infinities, equals 1. Since it's a probability distribution, it's got to represent probability. And therefore, the area under the curve for what we're looking at reflects the probability of it. We did say it was symmetric. It is symmetric about the mean. Which is the mean. On a bell curve, that happens to actually also be the median and the mode. The values increase from left to right, like a number line. Homeschool concept?
Yeah.
That explains why she's fucking torturing you with bullshit. It's your equivalent of an English class. This makes more sense. Well, I should find out your mom's email and email her some good books that she might like, that you'll like. And you can have a book that she assigned, but you'll like. Now you got some consistent in your college senior to help you. The Historian is a great book. about tracking down Vlad. Vlad the Impaler. The history of Vlad the Impaler. Also known as Dracula. Good book. Alright, this feels like a fun fact, but it's not, it's necessary. The graph actually never touches the number line. Line below it, which we call the x-axis. So let's say we're looking at like an area underneath the curve. And I'm gonna just shade a particular area, and we're looking at this red area here. The red area in the graph represents two things. A is the proportion of the population with the trait. And B is the probability that a randomly selected individual possesses the trait. And it's something you might like. Homework usually says normally distributed. Which tells you that you're using a normal distribution and you're using this calculator. Y'all have seen like equations in math, whether you like them or not, right? The equation for the normal distribution, which you do not need to know, fun fact. Let's put fun fact right away. Fun fact, which means you don't need to know it. The equation for the distribution, unless you're gonna be like a science major. Or even better, a statistician. That's not better. What am I saying? That is nowhere near better. So 1 over the standard deviation divided by the square root of 2 pi. And then it's the exponential function raised to the -1/2 x minus mu over sigma squared. This is what you got out of working with it by taking an intro to stats course. This isn't actually that bad when you, well, yeah, it is. What am I saying? It's bad. It's not the worst. There are worse things in like mathematics, but it's. You're good at math, it's not as ugly as it looks, let's say it that way. It looks hideous,
Those people asking questions on Saturday and like.
right? It's
Right.
really all subjects in there, all math subjects, even some computer science. Now, not all bell curves are the same. I could have a bell curve like this. Where the standard deviation might be 1. And it might be lower in the middle, but higher on the ends. And that one might be a standard deviation of 2. Or it could like spike in the middle, but get really flat towards the ends really quickly. And that one might be like a standard deviation of like 1/3 or something like that. You never know. They come in different shapes. They are all symmetrical, they're all bell shaped, they have all the other properties, but like they're not one size fits all. Go back to this red property that I was talking about. Let me give you an example of this, like I don't think that's a very good one, so like an example of part 5. We're gonna use one that we've used before. The IQ test. Has a mean of 100 and a standard deviation of 15. If we look at IQ scores. Between 85 and 130. '85 is 1 deviation to the left. 130 is 2 deviations to the right. So we're looking at something like this region. Now. Remember the empirical rule? Like each region had a value. The empirical rule. Says that this is 81.5. Or, well, 81.5%. It would show up as 0.815. As a probability. I have a random Zoom user on here, I wonder if it's Victor. Just says Zoom. Zoom user. If it's you, Victor, I just blew you a kiss. So applying this to the thing we said above. The 81.5%. 81.5% is the proportion of the population. With an IQ between 85 and 130. That's option A. B. If I randomly selected an individual. probability that their IQ is between 85 and 130 is 81.5%. That's a little clearer. I'll pick you up. Ever? Drive? Your dad pick you up? How do you get home?
I don't.
That's a bold move on their part. I don't know if I trust you with a car. No, young ladies drive better than young men. That's just. Switches when you get older. Old women drive worse than old men. At least every old woman I know drives worse than the old men I know, including me. You're found. In your grandma face. That's great. I love it.
It was my dad.
I love the fucking grandma face.
So he wasn't even gonna be on the phone, just.
Okay, that makes me more.
Alright. You guys ready to get some more? Fun fact to know about, wait, let me make sure. Folks are done writing that, some people are still writing, so I'm being all pasty over here. You're gonna have to just swing by your house and knock on the door and say. Hey, Mama Whitney, you don't know who I am, but it's Whitney, right? Hey, Mama Whitney, you don't know who I am, but I'm Krista's teacher, and here's a good book for her to read. And she'll be like, what, who the fuck, what? No, I've never gone to a student's house. I know I can find out where anyone lives. And if you like stop showing up and never call or anything, I might like send the police to knock on your door to make sure you're all right. But I'm never gonna go to your house. Random, just bizarre statements of make it sound all creepy, threat-like for no fucking reason whatsoever. The good times. It's fun being an asshole sometimes. Alright, so it is a continuous distribution. All the other ones we've done were discrete. There were countable numbers, even on the Poisson. We count the hurricanes. They came in integer values. It is a continuous description or distribution, which means the probability that x equals any specific value is 0. Like the probability of getting an IQ of exactly equal to 85 is 0. Because it's just a single line and there's no area under the curve. Just a single line, no area. Where that comes in is that like less than or equal is the same thing as less than. And greater than or equal is just the same thing as greater than. So ready for an example problem? Oh, I should get stat crunch up while you guys are working. Oh, it's Anaya. Hi, Anaya. I didn't blow a kiss at you, it's just for Victor, I'm sorry to lay you down. Oh, math lab. Kristen. Always really fun when a test date comes along and it's been postponed and like we've moved it to a different due date and we've like talked about it like every day in class for like a couple weeks, and then on the test day. The student emails me and goes, I know we have a midterm or a test today, but I can't make it today, sometimes it's. I don't feel so good. Can I take the test another day? And I'm like, yes, you can, so you can do along with everybody else, test is today. But like, I know you haven't been going to class or paying attention or watching videos or anything. Like if you like didn't know the test wasn't today, and yet I got an email from one of your peers. Today about it. Good times. What,
Is it trying again? Didn't work.
right? For those of you that came in late, the midterm is going to be at home. I will send out an announcement about it. After we're finished with chapter 7, I'll still give you a week to do the homework of chapter 7, so you learn everything. But I'll send out that announcement this week on when it'll be, and you'll get to do it at home, and you get to do 2 tries. And use the best of the 2 tries. While I would encourage you not to cheat. And look at your notes, I have really no way of stopping you and knowing that you did or not. So use your own, it's on your own. What's your integrity worth to you? I'm never gonna know, so you're only gonna be the only one that's gonna know. What your integrity is worth to you. Alright, problem we're gonna try. Then the weight of giraffes is normally distributed. With a mean of 2,200 pounds. And a standard deviation. Of 200 pounds. Start off with. A. Draw the normal distribution using the empirical rule. Like with the 68, 95, 99.7% mark. And then we're going to shade the area. To the right of 2,500 pounds. And your job will be to tell me, what does the shaded region represent? Well, you know it's got a bell shape, so draw a bell shape. What goes underneath the peak? Why? The mean goes right here. So 2200 is right here. What do the 68, 95, and 99.7% represent? From the empirical rule. Yeah, 1, 2, and 3 deviations. So this is the 68%. Then we'll go out another deviation. To represent like the 95%. And we'll go out a third deviation to represent 99.7%. What values go underneath it? I can think about this. Try to fill in the rest. Let's go back to your notes. We've done this before.
Like fill in them. Like would be
What goes underneath each of these dashes?
it 200, right? Plus on one side and minus on the other side.
How are you doing that? That's correct, but why?
Oh,
Why did you pick the number 200?
well,
Just because it's in the problem?
Yes.
So if I had said like over 10 years, you would have thought 10 was an important thing? The 200 is important because it's the standard deviation. So this is +1 deviation, +2 deviations. +2 deviations, this is -1, -2, -3. There are problems throughout, like the fucking homework problems that have numbers in there that don't mean shit. They'll like tell you when a previous survey was taken. Like the last time this was done was in 1982 and like. Like 10 people would be like. Where do I put the 1982? It's the fucking year, it doesn't go in the problem. Just because the number shows up doesn't mean it's a problem, but in this case it does. So I'm gonna add 200 each time, this will put this at 2400. This is 2600. This is 2800. I'll subtract 200 going the other way, so 2000, 1800, and 1600. Everybody got their chart down? Now it says shade to the area to the right of 2500. Where do I put it?
Right between 24 and
2500 is between 2400 and 2600, that's 2500 right there. And we're gonna shade to the right. Now, this isn't on one of our empirical rule lines, so we can't actually use the empirical rule to figure out that value. But we can use StatCrunch. Let's go find this value in StatCrunch and see what it represents. Or let's at least find the value and let's talk about what it represents. Let's find. What am I gonna put in my probability thing here? Well, it's gonna be X, they always use X for everything. Do I use less than or greater than? What? And why did you say that?
Because it says it's greater than is. right?
It's shading numbers to the right, and the numbers to the right are greater than the number 2,500, right? That's one way of wording it. And it's a good way of wording it, but like, for everybody that's like, I don't know what to fucking pick. Look at the number where your shading is it greater than or less than, is it a bigger number or a smaller number? This is not rocket science. You can identify a bigger number versus a smaller number, especially when it's. If I said I was giving you $2,800 or $2,500. I'm pretty sure you're gonna be happy with both, but you're gonna be happier with $2,800. Cause you instinctively know it's big. So this had a mean of 2,200. And a standard deviation of 200, those are needed in StatCrunch. And we're gonna go stats, calculators, normal. Can't spell. Can't spell normal, just abnormal. Taco Tuesday. It's Discount Pizza Tuesday at the fucking. Burger restaurant, I better call my wife to see what she wants.
Also, Bojo Tuesday for that.
It's what?
Bojo Tuesday for that. Buy one, get one.
I don't know.
Where,
Have it,
is it?
that's a rare.
Like, is it like just a burger or any meal?
Well, they have coupon, they have like a Bojo coupons for if you're like signed up.
Alright, I know, if you have the app, you get the BOGO, but what,
Today, it's the buy one, get one, or chicken. Sandwich, I think,
do they have a different one every day?
every Tuesday, or the last couple of Tuesdays.
Oh, huh,
I don't know how long the last, but
there's a fun fact for you guys. Abbott has buy one, get one on Tuesdays. Alright, I'm going to switch over to PC, assuming, is it, wait, I see some pins still going, hold on, wait. Don't yawn, Val, only I'm allowed to yawn.
Okay.
Do as I say, not as I do.
They probably did.
That shit was stuff my mom would say.
I can't laugh.
Every parent has said something along those lines. Probably not worded that way, but it is what it boils down to. Do what I tell you, not what I'm doing, but what I tell you to do. Yeah, I'm doing exactly what I told you not to do, but guess what? I'm a fucking adult. I get to do that. You're the kid, you gotta behave.
That's all my son about cussing.
You what?
My son, that's what I tell him about cussing. He's like, you cuss. I was like, I pay the mortgage here. That's equal. That's good.
Alright, you guys ready? Stats. Calculators. The fucking Zoom bar's in the way, god damn it. Stats, calculators, normal. We need the mean. We need the standard deviation. We were aiming for 2,500. And it only gives us two choices. We said we wanted greater than, this says greater than or equal to, the equal to proportion does not matter on the normal distribution. So that's what we want, and that kind of looks like a graph, right? Well, ours was flatter, mine was flatter, that's just because I was at the bottom of the page. And I didn't want to make it tall, right? So it's giving us this number right here, I'm gonna go write that down, and then we're gonna switch back over. Do this, and then we'll come back over here and play around with the stuff. Actually, maybe we'll play around with it now. Less switching back and forth. So we can do that, we can do, I wrote down the value, we can say less than, and we could change this to like 2,000. You can change it to 2,200. What do you guys think 2,200 will be? No. What is 2,200? It's the mean, so it's the center of the graph. How much area will be less than it? Half, 50.5. We can also do between. And it always defaults to -1 and 1, which isn't applicable here. But I could say like 1,900 pounds and 2,100 pounds. And that's clearly not, oh, that says a negative number. There we go, now it's shading the right region. And so we can do stuff like that. We're gonna do more with that calculator in a second. It does have some kind of neat stuff. Why doesn't it have it here? Notice that it defaults to 0 and 1. We're gonna talk about that next. Shit, it's not down here either. They used to have a 68, 95, 99.7 button that you could click on and it would show the values underneath that matched up with it. These are already shown. I guess it's doing it by automatically now. Yeah, it's doing it automatically now. It used to be something you clicked on. It used to not be automatic. It used to be like it picked whatever numbers like looked good for it. And it was not always like the 1, 2, and 3 deviations. Huh, they made changes for the better. Alright, I'm gonna switch back. Alright, so that's what we had here. So what is that number telling us right there about the 2,500? Cause that was our question, what does the shaded region represent?
Pick the random graph is 6.7% chance that it will weigh over 2,500 pounds.
We picked a random giraffe. There's a what?
6.7% chance that it will
That seems like a valid rounding, 6.7% chance that what?
weigh over 2,500 pounds.
That it's over 2,500 pounds. I'm trying to make sure I had all your words and like. I know what my answer is. That's what Krista says. Is that right? Does it seem right? Makes sense to me, right? If I shift it over. Fortunately, it's not enough. It's an incomplete answer. What was the other thing that a shade reader represented? It is correct, that is correct. You got that part right, you got it half right. It's also the proportion of giraffes. That weigh more than 2,500 pounds. pounds seems kind of heavy, right? How does it compare to like an elephant? Is like a 2,500 pound giraffe, seems like it's pretty heavy for a giraffe, would it be heavy for an elephant? I have no idea. Usually it's really hard to compare things of different species or categories. So something we do when we want to compare things with different categories. We can shift to z-score. I think me and Krista did this, or it was me and Val. Height, we found our z-scores. We did do this,
Yeah.
okay. I knew I compared my height to somebody, I wanna say it was Val, I think we went back to back. So that's like starting with any particular X value, which is the individual score. Equals mu plus z times sigma. That's the mean for the group. And that's standard deviation for group. Which means z is the number of deviations away from the mean. And we solved that for z before, we had z equaled x minus mu over sigma. That was the equation we had before. And it's still valid. So if you want to compare z-scores. The z-scores have a normal distribution as well. It turns out the mu of z is 0. And the standard deviation of z is 1. Which were the default settings in StatCrunch. And this particular deviation or distribution has a name. It's not just a normal distribution. This information right here is called the standard normal distribution. So let's look at our giraffe. Our giraffe had a weight, like let's say we had a 2,500 pound giraffe. We had mu was 2,200 and standard deviation was 200. So z equals x minus mu over sigma, which equals 2,500 minus 2,200 over 200. Which is 300 over 200 or 1.5. So if we wanted to do the weight in like StatCrunch. On StatCrunch, we would want the probability that Z was greater, we had X greater than 2,500. This is gonna be Z greater than 1.5. Now, the fun shit is this. In the modern day and era, you're gonna have computers do this shit most of the time, and. For the most part. If you're not. In standard normal. There's really no reason to convert to it in today's day and age. So long as technology works. That's a pretty fucking big disclaimer. Technology working requires computers to work. And if we have World War III, that's the first thing that's fucking gonna go. Then you're gonna target electric grids, you're gonna target electronics. Knock out electric centers, knock out shit like that. If we have a global apocalypse, a World War III. Like, we can kiss technology goodbye for a while, and then Z-scores become really handy. If we have World War III. Tech is probably wiped out. I know that would be what I would do if I was a superpower, if I was the leader of a country attacking another country, I'd attack the electrical grid first. Knock out communications, knock out intelligence, knock out all sorts of shit. Knock out any weaponry or anything that relies on electricity. Fucking good idea. If that's the case, then Z-scores are gonna be great again. Because they'll have to burn every stats book in the fucking world to make this irrelevant. Every stats book. Has a Z-score table. To find probabilities. Now, hopefully that doesn't happen. Hopefully. Probably will one day, but hopefully it's like well past your grandkids. Kids' lives, I don't know. Trump's definitely trying to pick a fight with fucking Europe right now. I don't know if you guys saw what happened on Friday. He fucking went to town on Ukraine. Like it was like a fucking bait switch trap, it was terrible. And Europe is all fucking rallied around Ukraine and fucking we look like the bad guys, totally do. But like if he calls it, I don't know, if we have a world war soon, it's probably gonna be him. Hopefully not though. When you have a wild cards are what cause chaos. Whether you like him or not, he is chaos. He's the fucking Joker of the Batman story. Great character, but chaotic. Alright, so we probably won't use it that much, but it's there, it's available. You might, if it does come up, you will see stuff with it, they will give you questions on it. If we see. Z with like a number underneath it, like Z 1.2. This is referencing probability that Z is less than 1.2. It's a less than scenario. So this prompts us to find. That Z is less than that number, whatever that is. And for some reason, and I don't know which jackass came up with this. But they'll also have Z alpha equals 1.2. And for some reason, the alpha symbol means, or Jesus fish, as some people like to call it. It means switch it around, do greater than 1.2. So the alpha means go to the right. That is alpha, is the Greek letter alpha. In fact, every once in a while at churches, you will see that along with that. Alpha and the omega. Depending on the religion your church you're going to. Some of them have that in there, that's one of Christianity's gigs. But for the most part, if it's not a Z-score, really, like when you're doing homework or the midterm and shit, there's really no need to convert to it. And I'm not gonna make you use the tables. I'm not gonna show you how to use the tables, cause you'd be like, huh? Fucking tables are, I had to learn this shit with tables. It's fucking torturous. It's fucking torturous. So let's look at another example. There you go. Three more problems and we're done with both 7.1 and 7.2. Do you guys want a 10-minute break first or not? If anyone wants to take a break, let me like just stand up and go to the bathroom right now. Not in here. Don't get no ideas. I gotta be specific about. I don't know, she might have a diaper on, you never know. God forbid that, I do not wanna be in those days. God. That's,
Coming up quick.
I hope not. Well, no, I kinda, well, I'm torn. They are coming up quick, but that means like I'm getting old as fuck. But I'm still alive. And that means I still have a chance to be made into a vampire if they are real. But I don't know. Alright, no one wants to take a break? You manufacture distance. Bake cupcakes. Let's personalize this bit. You bake cupcakes. Defective cupcakes. Deviate a lot from the mean by weight. So like Kristen bought in those 12 cupcakes, the dozen I bought a couple weeks ago. If one of them was bigger than the rest. I would be like, why the fuck aren't they all this size? Or like if one of them is smaller than the rest. I'll be like, why the fuck did you give me a rent cupcake? So like if they're close enough to each other, their weight's gonna be about the same, and I'm not gonna be able to tell the difference if they're close enough, right? So like even in cupcakes, this matters. You don't wanna have one that's just a different size than the other, for any reason. They all need to look uniformly the same, otherwise, someone's gonna go like, oh, I know you can make them bigger, why are the rest of these small? Or like, why did you give me a fucking lane or same donut, a lane cupcake? So you want the same size cupcakes. You decide to. Not sell, I was gonna say scrap, but you're not gonna scrap them, you're gonna eat them or fucking give them out to family. You do not decide to not sell the cupcakes. That. Are in the lowest and highest 10%. Weights. I don't know what the mean weight of a cupcake is, so this is a perfect opportunity to use the fucking Z-score system. Alright, so we're gonna use Z-scores. So on my curve. I wanna knock out where this is 10% over here. And this is 10% over here. Those are the ones you fucking sample. Or give out as samples, where they're not in the box, they're not looking. That's probably what the 13th cupcake was, it was the one that was off by weight. She seems like she's the type that went through the whole, let's weigh in and figure it out. Probably, did you measure the scoops or some shit, cause they all did roughly look the same size,
I just hope it's not the same.
there you go. It's already winging it, new baker winging it. That looks like shit, that doesn't look like 10% on either side the way it is, but it's enough to go by. So like this looks like we're looking for the Z-score here. Like say that equals A, this one equals B. Since it's symmetrical. Like these should be equal and opposite, like A should equal negative B. But let's show you how to do this in StatCrunch. Just wait until make sure everybody looks like they're done writing. Yeah, she's just like a fucking, I'm going to sleep. At least fake, there you go, at least fake it. No, night classes, they can be tiring, you've had a long day, night class can be tiring. Trying to make it entertaining. Alright. Alright, so we got our Z-score thing over here. If I want the inner. If I want 10% on the left and 10% on the right, how much should I have in the middle? I should have 80, right? Should be 100% total. And if I knock off the 10 on the left and the 10 on the right, I should have 80. So let's call this 0.8. I'm gonna change this box, not the between boxes. I'm gonna change this box and watch what happens. It fucking tells me the Z-scores. It'll give you the Z-scores. So you don't necessarily need a Z-score, you can look for like. Or you don't necessarily need the weight, because you're probably not gonna be worrying weight or Z-scores. But like, let's say she fucking weighed her cupcakes and had or looked up cupcakes and their standard deviation. And she tried to stick with that. She could like try to figure out what weights are too far beyond. Yeah,
So the 0 and the 1, like if you're doing that, like say for homework, it will always be 0 and 1?
yes,
Okay,
if I click on stats, calculators normal. It always pops up as 0 to 1.
so it defaults like, okay.
It's the default. Chances are you're gonna, like, if it's, there will be problems on the homework that say work in Z-score, that one's there. The ones that are word problems are almost always like give you like. A mean and a standard deviation that is not 0 and 1. And that's where you just go through and change it like we did with our giraffes. So you just change it and edit it. Now, this says X. But it really means Z. When the mean is 0 and standard deviation is 1, this is a Z-score, not an X-score. They don't fucking make a difference. Like, they're like, we're not gonna reprogram it. They don't do one for each because that's just more shit to have in there. And they're really the same value, it's just a different letter. So. Apparently, the Z-score we're looking for is. We'll say 1.28. And it's plus or minus 1.28. Notice that they are the same number other than a negative sign. Remember back to chapter 5 when we were talking and we did the whole. The box plot and shit like that, we were talking about percentiles and stuff. A percentile applies here as well. If you wanna do a percentile here in StatCrunch. A percentile, you use this one right here, the X is less than. And you change the percentile that you want. What is the average SAT scores? Let's assume that. AI knows what this AI knows what it's talking about. I'm not confident of that, but it's enough for my example. I'm gonna set my mean, wait, what was the deviation? 100. So I'm gonna set the mean to 1024 and the standard deviation to 100. And I'm gonna say, what is the probability that like. I was in the 98th percentile. 98th percentile means 98% of students got a score lower than you. I would have needed to get a 1229, 1230 on the SAT to be on top. That doesn't seem like it's the average. To like be in the top 2%. I thought they went up to 1600. What's the highest SAT score? There's no way. This, whatever AI gave me, was fucking bullshit about the mean standard deviation. Let's look at that one. There's a lot of them that have like, oh, let's see, California, we're dumb shits. We had a fucking mean score of 1055. Look at some of these other states, Iowa, 1275, fucking a lot higher. Standard deviation, there's the kicker of what they got wrong. Let's use what California had, 1055 and 186. That seems more likely, 1055. Like, there's no way to get up to 1600 if you got 1024 and 100. And if I wanted the 98th percentile. That seems like a higher score. 1437 seems like a pretty good SAT score. So like whatever the fucking AI bullshit gave me the first time, that shit is wrong so goddamn often. Like you have to know it's wrong so you can be aware of it. I haven't just looked up math shit, I've looked up shit for Denver Junior College or Carl. And it would tell me shit like I knew was wrong. Like flat out wrong. Like it's wrong so goddamn often. Or AI. beloved by so many students. That submit shit that they see on AI, never knowing that they look like complete fucking morons because they're submitting stupid shit that doesn't even make sense. Don't submit AI shit. AI won't help you on your take home midterm. Now, most of them are word problems that are worded real funny. You think AI is gonna be able to read that shit and make sense of it? No. Don't use it. Try to do what, like, you'll have the review video and shit. Let's do another problem. Let's go back to the screen. So we showed percentiles, we showed, I said gizmos to start with, but we did cupcakes. Let's write out a couple ones real quick that you might see and then go do them all at once in the computer. How about that? Knock out 2 problems at once. So first problem we're gonna look at, I'm sure is related to one in the homework, I've seen these before. A steel rod company. Produces, obviously, guess what they produce? Produces steel rods. With a mean length of 100 centimeters. And standard deviation of 0.45 centimeters. Okay. What is the probability? Selecting a rod. Randomly. That is shorter than 99.2 centimeters. Question mark, so I'll put a question. What would that be in math jargon? Why? It's smaller, shorter is smaller and smaller is less. So that seems like a reasonable assessment. What about if we do? Between. 99.7 and 100.4. We're just putting those in. So we'll calculate that. And then let's look at like, what are the middle 99 or 90%? What are the scores for the middle 90%, or the lengths? For the middle 90%? Let's do a D, what about in Z-score? For C. Or C. I'll show you how to do that. Then our next question is about. The gestation period of human pregnancies. Gestation period, if you're not in the know, is how long is the baby in the oven? The bun in the oven. How long is the baby cooked? So what? The average is 266 days. Which is approximately 9 months. Standard deviation is 16 days. So we'll ask some questions here. A. What percentage of babies take more than 270 days? Which is 9 30-month days. Or 30-day months. Very preterm. Is less than 224 days. Or about 7.5 months. What's the percentage there? And then let's do the inner 90%. Rounded to the nearest day. That last one's a little trickier than all the rest. Everybody write this down, then we'll throw them in StatCrunch. And wham bam done. Sure, it's got it done written down. How you doing, Kelly? Are you writing or drawing? Hang in there, still writing. I was telling the trick class about the rounding error issue with homework. And how students are just like you. She literally threw her hands in the air on Saturday, like in frustration. It was something like a rounding error, so I'm like, it didn't go that high, she just did that.
I didn't put the fourth decimal or
But
number,
yeah, it would ask for 4 and she did 3 or some shit.
and I got it wrong and had maybe have an.
And she assumed she didn't know what she was doing and. Just brought it over to me, like, well, let's read the problem. Alright.
The kid inclusion, I need to pay attention to how.
Alright, so on our first one, we have a mean length of 100. Let's change this to 100. And a standard deviation of 0.45. And they started off asking us less than, we gotta click on the standard button up here. And we want less than 99.2. Looks like maybe if we do 4 decimal places, 0.0377.
Is that the button you were talking about? The 68.95.
Motherfucker, what the fuck? It just shows up out of nowhere. I was trying to get it to fucking show up earlier and it fucking wouldn't. These
Right.
dizzy motherfuckers. Yes, that is what I was trying to show you. Maybe it's when they're decimals here. Maybe if it's gonna be a whole number like an integer, it doesn't bother doing it, but like. And it's something you can toggle on or off. Alright, so we got that one. The next question was between 99 and. Let's turn it on. It is on. No, it isn't. Turn it on. Let's do between 99.7 and 100.4. Point 5605. I can start typing a list of what we had. We had 0.0377. We had 0.5605. Here we want to do the middle 90%. We're gonna change that to say 0.90 on the right over here. Click compute. And let's say 99.26. Up to 100 100.74. If I want to find this on z-scores, all I gotta do is change this to 0 and 1. And do 0.90 here. And we find the z-scores are 16449. Now, we had. There we go, 68, 95, 99.7. I put it back up here real quick, just to remind you, these were 1 standard deviation, 2 standard deviations, and 3 standard deviations, right? Those were the percentages from the empirical rule form table, that formula. Let's look at what they actually are. If I do at 0 to 1 and I say between -1 and 1, that is within 1 deviation. I should get it to say 0.68 over here. That would be 68%. Notice that it's not quite 68%. It's a little bit higher. The empirical rule is designed to give you fast numbers that are close enough. So within 1 deviations, that we say 68%. It's really closer to 68.27%. When we say 2 deviations, we say 95. But this one's almost 95.5, it's 95.45. So it's almost halfway between 95% and 96%. We still like, we're only using it for like approximate things when we do empirical rule. If you need actual values, you come over here and do shit like this in the computer and do actual calculations. The empirical rule is designed to give you a quick outcome of what the middle 95% would be. Does that make sense? And if we did 99.7, which this 3 deviations should be 99.7. Well, it's close to 99.7, but it's a little bit more, not more, not much more. The 95% one is the one that's off the most. All right, then we have the one with the mean of 266 and standard deviation of 16, our human gestation period. And we wanted, what percentage of babies take more than 270 days? If I don't know and I put this in, that doesn't look like it's shading more. Does it? It's giving me numbers that are lower than 270, which tells me my sign is wrong. So if you have the wrong area shaded, it'll fucking tell you, if you just think about it. Just think about it, use reason. So more than 270 days is almost 40%. 0.4013. Then we wanted very preterm, which was less than 224. And the 3 to 4 decimal places, that is really low. It's less than 1%. 0043. And then we wanted the inner 90% rounded to the nearest day. So I'm gonna write down 2 values right here and we're gonna show what happens. Oh shit. Over here. 239.68 and 292.32. So what would the nearest day be for 239.68? 240. What would the nearest day be for 292.317? 292. Watch what happens when I calculate the z-squared or the percentage. It's not 90% anymore. So if you want to capture the inner 90%, and that's more important than which way you round, we got to round the other way. So we showed 240 and 292, but that led to 0.896. So maybe round outward. So round outward. I'm gonna go back and put the 0.9 in here and look at outward. Rounding outward will on the left side would be rounding lower. Does that make sense? If I want to go like outward, like from the center, I would round down to get a lower number, even though that's not the correct way to round. I'm gonna round outward. Rounding outward on the right side is rounding up, even though that's not the correct way to round. If I do 239 and 293, I now have above 90%. And if the 90% was important, you're gonna go with these numbers. Homework problems will throw shit like this, like at you with like enter percentage and say round to the nearest amount. When that happens, if you get the answer wrong, just go, did I round outward? Go back and retry it to round outward. Okay? That's it. That's all I got. GTFO. Or stick around and ask questions. What about this cat? I think you already know it was chicken sandwiches. Are you like stopping there on your way home or some shit?
But I have it in my app.
What? Oh, it has a fucking line there, doesn't it?
Oh, I don't know how many people actually use that. they were doing